This is part 3 because I've forgotten to highlight few things. I'm not quite satisfied here. Okay, remember this now feature 4, right? I was explaining this graph. Okay, so in feature 4, if you notice this graph, the line here is the dot here is F0, is a threshold frequency here. Okay, the intercept on the x-axis, and then you will notice that k max is equals to 0. So therefore it's actually, if we put hf equals to w plus k max, okay, hf equals to w plus k max, okay, if k max is 0, you notice this is 0, so hf is equals to hf naught. Okay, alright. Then after that, from there, the lines here you will notice is a frequency which is greater than frequency f0. Okay, and when the frequency is greater than the frequency f0, the more the frequency increases, the more the k max increases. Okay, that is one thing about this graph. Another graph, I should have explained this graph also, because of you remember this figure 24.4, we notice even though light intensity increases, it does not affect the stopping potential. So stopping potential is not affected by the light intensity. But there is one thing that will affect the stopping potential. And that stopping potential will be affected is by the frequency of the light radiation. Because we notice when the frequency of the light radiation increases, we notice the stopping potential also being affected. Okay, which you see it's also increasing. Vs is also increasing. Alright, so this is one thing I want to explain about this graph. Okay, and next is the thing, another one more is about this number 7 and number 8 in the features 4. Light of great intensity consists only of more protons. You see class, if this is the metal and this is a light radiation, E equals to HF, and when the electron absorbs the light, the energy, what happens? The electrons are ejected with a K max. Okay, so whatever energy left inside the electron, it is a maximum kinetic energy. The concept says the K max depends on the frequency in this feature. The greater the frequency, the greater the K max. But according to wave theory, it shouldn't be like that. Wave theory says that maximum kinetic energy should increase with light intensity. But light quantization says if you increase the intensity, it only consists only more photons. Okay, that means if you increase the intensity of light, only more electrons will be released. And when more electrons be released, that means more photocurrent is detected, which you will see here, which it will go with the current saturation. It will tally here. But even though more electrons are released, it says, however, the energy of the each photon remain the same. Okay, so that is what I want to add into this. Okay, so this quantum physics, you have to first understand how the photocell circuit happens. Then you will understand how these things are contradict. Okay, so at the end of the concept of photon or photoelectric effect, what we should know that light is considered as a wave particle duality. It behaves as a wave, it also can behave as a particle. So but under quantum physics. Okay, alright, so that is all.